Hello, IdeaXme listeners. Thanks for tuning in. Today I'm talking to Dr. Liz Warren from CASIS. Liz, please tell us, who are you?
I am a curious mind. I'm a scientist. That means I like to ask questions. I like to explore the world around me, and specifically, I am really interested in space and how going to space changes the way we see everything, really, from the way our human body works, to the way fluids behave, to the way fire behaves. So I really like to see the natural world around me in an environment like space.
When and how did you know you wanted to work in the sciences?
I am one of those people that believes that we're all born scientists. Anyone who's ever met a kid knows that they're full of questions too. Why is the sky blue? How did that happen? I think scientists are kids that just didn't really grow out of that phase. So I think my answer when adults used to ask me what I want to do when I grow up, I think it has always been to be a scientist.
Tell us a little bit about your extraordinary experiences. In reading your history and in chatting with you and other times, I'm aware that you attended space camp at one time. I've also seen some of your postings about travel destinations that you have visited for science projects.
Yes, like you said, I like to travel. And that, I think, got instilled in me. That enjoyment of travel got instilled when I was a kid. Again, my parents were pretty supportive of my curious mind. They liked to travel, and they were kind enough to take me on several trips around the world. And so at a pretty young age, I had my eyes opened to the world around me, different people, different cultures, different places that looked a lot different than where I grew up. And so I think that love of travel has stayed with me. You also mentioned space camp. My parents were fortunate enough to have the resources to send me to space camp. I, of course, also had an interest in space. I found this news article or pamphlet about space camp, and it looked like something that I really wanted to do. And my parents sent me to space camp when I was in late middle school, maybe early high school. And until then, I hadn't really met a lot of other young people with the same interests as myself. I didn't know anyone else that liked space. It made me a little bit of an outsider. But when I went to space camp, everyone there liked space. And so it wasn't just an incredible learning experience. Going to space camp, I found other people with similar interests like myself, and I didn't really have that. I didn't have many friends growing up that also liked space. Mm-hmm. And so going to space camp, I met a lot of other kids. Every other kid there liked space. And so that was validating for me that I wasn't, too unusual. It was mm-hmm. I found my tribe when I went to space camp and discovered that a lot of people liked space and that it was an actual industry that I could work in. So that was validating and affirming for me.
Do you still keep in touch with your fellow space campers from back then?
I did for a while, actually, for a long while, but I have fallen out of touch with people that I went to space camp with at the time. However, there's a strong alumni network, and every year there's an alumni festival weekend where they try and get as many people as possible to come back to space camp, see how they've advanced their programs. They have an auction to support scholarships for space camp. And so I support and I go to that as often as I can.
Some people here in the United States were under the impression, especially from the movie back in the 80s, that space camp was only for kids that wanted to be astronauts. But I'm getting from you that it's kids that are just generally interested in space overall.
Yeah, they also have a robotics camp and an aviation challenge camp that is more geared toward aviation. I certainly wanted to be an astronaut growing up, but one of the benefits of going to space camp is getting exposed to several of the industries that support space. Mm-hmm. As you know, the astronauts are really only the tip of the iceberg of our space program. And it takes thousands of people to make our space program work. There are scientists, engineers, people that develop new technologies. There are lawyers. There are artists. There are administrative professionals. So the industry that supports space is much bigger than just astronauts and the people in mission control. So I think that going to space camp opened my eyes a little bit to the fact that there is more to the space industry than just the astronauts. It exposed me to a variety of positions and jobs.
During your studies or your experience at space camp, or during your educational career growing as a scientist, what was a moment where you're working with an experiment or studying a certain science where you made a discovery or something that really impacted you?
Well, I'll tell you, as a young scientist, as a young investigator in college, university, or even in grad school, when you start to formulate your own hypotheses based on something that you've read, and it piques your curiosity, and you wonder, I wonder what would happen if XYZ. And so in my case, I was really interested in gravity, but it was not super accessible to be able to send a experiment to space. Mm-hmm. I was lucky, however, to work in a laboratory that had kind of the opposite of space. It had large diameter centrifuges. And a centrifuge allows you to increase the gravitational force on an object or your experimental sample. So going to space is, we say zero gravity. That's really a misnomer. It's microgravity. But for all intents and purposes, let's just say that you and I right now are in 1G, 1 Earth's gravity. If we were to go to space right now, we would be in much, much, much reduced, almost zero gravity. I looked at things also in hypergravity, or additional gravity than what we experience right now. I was really interested as an undergraduate and as a graduate student in metabolism. We looked at the exposure of, actually my dissertation was on the effects of gravity levels, either plus gravity or minus gravity, on the metabolism of rats. And so I would put rats on a centrifuge and had also the opportunity to get some samples from rats that were in space, zero gravity, if you will, and study the differences between them. And so having the opportunity to do that is extremely exciting. And as a scientist, when you learn about something and then formulate your own hypothesis, design a test to test that hypothesis, and then get a result, that is extremely satisfying. I equate it maybe to an artist finishing a painting or a musician finishing a composition. It is good for the soul.
So what was your final discovery? What was the conclusion? How does gravity, does it make metabolism slower, faster?
Well, to say I concluded conclusively about something is a stretch. I really just advanced the knowledge. And I looked at a couple of different hormones that are involved in energy balance and control of energy balance, and saw that gravity changes the sensitivity of some of these hormones. And that sounds kind of nebulous to say, but it gets a little bit complicated if we talk about all the details. But it is an interesting perspective because NASA wants to send humans to Mars, for example, or other celestial bodies that have different gravity levels. And we have to consider, what will the nutritional requirements be of astronauts when they live on Mars? Will they need as much food as you and I here at 1G? It's not all that different than microgravity, but is there something in between? So it's an interesting question, and we don't know all of the answers yet. And so I think that's still exciting as a scientist, to know that we've learned somewhat what we will need to do to go to Mars, but there's still a lot left to learn.
Fast forward to today. You're here at CASIS now. Tell us a little bit about CASIS, what they do, and what your function is here.
CASIS stands for Center for the Advancement of Science and Space. We are a nonprofit, non-governmental organization that was selected by NASA to manage the ISS National Lab. And let me back up a little bit. Back in 2005, when we were still building the space station, Congress made into law that the space station was requiring a lot of resources and therefore should benefit as many people as possible here on Earth. And so they decided that the space station should be a national lab. And what that means is it opens access to the space station to make it available to researchers in academia, in other government agencies like the NIH or NSF or DARPA or DOD, and also commercial entities, commercial companies like Pfizer, Eli Lilly, Google, other companies that may be able to utilize the space station to benefit their business and make low Earth orbit a commercially relevant place. So our real goal at CASIS is to help maximize utilization of the space station. And so that's what we work hard at, and it's really enjoyable. My title is Associate Program Scientist, and what I get to do is I get to speak with researchers and industries and commercial entities that maybe have never considered using microgravity in their own field and inform them about our incredible International Space Station, tell them how the space station may benefit their research, how bringing whatever they look at, whatever they're curious about into space may completely open up their eyes to a more complete understanding of their research, or it may even lead to a breakthrough, increases their learning exponentially, or informs them about their system. And then, so that's what I get to do. I get to tell researchers about the opportunities that are available and help usher their experiment onto the space station.
So are there any experiments that you've helped usher up to the space station that have really impressed you, or have you seen any data come back on any of these experiments that you think can really make a difference here on Earth?
Well, this is not something that I was directly involved with, but I will tell you about an experiment that recently got back from the space station. The idea for this experiment, the whole concept, the submission of a proposal, all the way to the PI getting the data analyzed was just under a year. I think it was actually like 364 days. So in some respects that may sound like a lot, but that's actually pretty quick for getting something from concept all the way through flight down to back to the ground and analyzed. And that was an experiment that was looking at a crystal that could potentially help cure Parkinson's disease. This experiment was actually conceived of and flown in space by the Michael J. Fox Foundation. As you may know, Michael J. Fox, an actor, has a foundation to help understand and cure Parkinson's disease. It's a pretty devastating and sad disease, affecting millions of Americans, millions of people around the world. There's a really interesting thing about microgravity and how it can enable scientists to better understand something. So I keep talking about these somethings or systems. This one in particular is called protein crystal growth, or macromolecular crystal growth. It's a little bit of a funny concept, but let me make it simple and say, in our bodies, there are hundreds of thousands of different types of proteins. And we have a pretty good idea of what they look like by using high-powered microscopes. But proteins are always kind of in motion, and they're moving, and it's hard to understand exactly what they look like. And the reason we want to understand exactly what they look like is if you know what a protein looks like, you can design a medication to either mimic it or inhibit it. That means to prevent it from doing something. So the proteins in our body are the machines that do work. So in some diseases, like a protein may degrade muscle.
Right.
And you might not want that to happen, but in a disease state, the protein is out of control and degrades muscle out of control. You want to design a medication to stop that protein. Without knowing exactly what it looks like, it sure is hard to make a medication work. But we take that protein, we bring it to space, and we try and crystallize it there to really understand its structure. Why do we do that in space? Well, on Earth, if we try and crystallize that protein, it's going to sink to the bottom of your test tube. It's going to sit on the bottom of your test tube and get a little distorted just by the function of its resting against a hard surface. In space, it will never rest on the bottom of your test tube. It will float. That and some other interesting variables about being in space make that crystal grow bigger and more perfect. And you can study it to better understand its structure. That will help you design a medication to, again, either inhibit or mimic that protein on Earth.
So I was looking on the CASIS site, and I noticed that Lucasfilms decided to design a mission patch for you all. How did that all come about?
Well, one of the unique aspects of CASIS is that we are encouraged by NASA and by Congress to investigate non-traditional relationships, meaning we can talk with companies like Lucasfilm and invite them to participate somehow in the space station to help us get the word out about the space station, to inform people, A, that we have this incredible laboratory in space, and B, that it's pretty darn neat. And NASA has some legal restrictions in how they're able to engage with companies like that. There's certain restrictions that are just legally bound by this, as a government agency. We have the capability of reaching out to companies like that and working with them to help publicize, essentially, the space station and what we do at the National Lab. And so that relationship, I think, actually was kind of serendipitous between our marketing team meeting somebody who knew somebody who knew somebody at Lucasfilm. Yeah. And they got introduced and decided that, Lucasfilm didn't want to do any research on the space station. They just couldn't conceive of how making movies would really benefit from space station. But what they could do is design a mission patch. And so that's what they did. And I think that's pretty neat.
Yeah, it is. Pretty cool. So my final question, who would you like to meet and why? When you look at heroes or inspirational stories, people who maybe were contributors to the expansion of the sciences in the past, or maybe somebody who's currently working on something that could be groundbreaking. And if you had the chance to meet them, what would you ask them?
So I'm gonna give you two answers. One of them related to the previous question. Again, when I was a kid, I was one of those Star Wars fans. I loved Star Wars. It helped me keep motivated and dreaming about space when, through growing up, sometimes there's times where, school either is a bummer or something happens and you're upset by something, but having something that you look up to is kind of like a guiding light. It keeps you focused, it keeps you inspired, and space has always been that for me, and Star Wars contributed to that. So if I could meet anybody, one of those people would be George Lucas, because I would love to meet him and thank him for providing a motivation for me to keep reaching for the stars. Another person that I would like to meet is a scientist. His name is Francis Collins. He is the director of the NIH. That's the National Institutes of Health. And he's a really neat guy. He's incredibly smart. He's also a musician. And they have a rock band at the NIH. I forget what their actual title is, but it reminds me, there's actually an astronaut rock band too. They call themselves Max Q. And I think the analogy there is, when you take people and you form groups where there's a lot of brain power and a lot of creativity, music can sometimes be the outcome. And so I think it's really neat that he has a rock band at the NIH. But I would like to meet him because just to talk with him about some of the big questions in science that are maybe yet to come. They're
Yeah.
still a little bit out there. As a society, we are making amazing breakthroughs in science every year. And if you look at where we are today versus just 10 years ago, there's profound hope for a lot of diseases that we previously thought we weren't going to make any headway on. We are closer than ever, I think, to being able to solve the shortage of organs. There's a lot of people that need new organs, like kidneys or hearts, and the amount available is just not enough to meet demand. I think we're closer than ever to being able to artificially make organs for people. And that sounds a little bit out there, but I would like to pick his brain and find out what's even further out there. What can we look forward to in 50 years? What's going to happen?
Yeah, it would be amazing to see. So a follow-up question, since you mentioned the arts. I have noticed on behalf of NASA and other STEM-related agencies or companies, there's a push now for, instead of STEM, STEAM. And just like you, I did witness astronauts or people that are very technical in nature and become surprised to see that there is an artistic part of their personality. You, as being a scientist, what do you have an artistic escape? And what do you think about this push for STEAM? How important the arts are for people who are technical or kids all around in school?
I think it's really important because it connects. Our brains are incredibly complicated organs, and the way our thought processes work, math is a very artistic science, really. Art is very mathematical, and music is extremely mathematical. So it's all intimately connected in the ways that our brains work. And for kids that may think that they're not good at math, or they just don't get science, but they're really good at art, I would love, for people to connect those and say, if you're really good at music, you're actually really good at math. You just maybe haven't thought about it that way, or you maybe, haven't tapped into that aspect of using what you do know into expanding your knowledge in a different direction. So I think that makes STEAM a really potent concept because it connects everything together in our thought process. And myself, I am very scientifically minded. I'm not really that gifted in mathematics, but I do enjoy art. I like to play around with photography, and I have tried to learn guitar and ukulele. With all three of those, I have noticed that if you don't practice very much, you don't get any better. So I struggle with that a little bit. But as all through growing up, I was always in band. I was a band kid, and I'm a drummer. So I've always, through middle school, high school, and college, played drums in either marching bands or symphonic bands. So I've noticed one other thing about how all of those things work in one's brain. If you let a part of your brain go quiet, you don't exercise it very much, like the language center. If you're not working on learning a new language, music I also consider, or math, as languages, they get a little quiet and a little lazy. But once you reawaken that part of your brain, it feels good. It feels good to use your brain. And I noticed this when I took a Russian language course over at NASA Johnson Space Center. I hadn't been playing music for a while. I hadn't been exercising that part of my brain. But when I started learning a new language, wow, that made me want to be musical. So something in the way our brain is wired connects all of these things together. And I think that's pretty special. I like that.
Well, thank you for taking the time to sit down with me for this interview. We wish you the best of luck in your career and in your future. And also we wish the best of luck to CASIS and the International Space Station on continuing to bring us all that knowledge and the results and the data. Listeners, just take a look at our links on our site that lead to information about Liz and her work and also about CASIS. Until next time, thank you.